Regression is what we're doing, what we did in this class, in the last class. Okay, regression is about finding and using a prediction equation, and our discussion, what we cover in class, is only limited to cases where we have a linear relationship between variables and interval or ratio scale variables. But I think that's plenty enough. That's plenty. So when you use regression, you define one variable as the outcome, and that is a dependent variable. Outcome variable, dependent variable, and the variable usually labeled as y, and you define the other variable as a predictor, that is independent variable, and this variable usually labeled x. So it's really like a math, y equal ax plus b or something like that. The goal is to create an equation that can be used to predict y using x. When x changes, y changes, something like that. Depending on the value of x, you get the outcomes value, which is y. And if you know the math, it's really easy to understand. But there's couple of things that are not the same as math. Okay, for example, let's look at this sample data, and this is data for temperature and coffee sales for 12 days at a concession stand. And this is a scatter plot, and the R is negative 0.86, strong correlation. And we might want to use our data to develop a regression model that could later be used to predict coffee sales using temperature, because this only tells you those 12 dots. But you want to be able to predict, maybe, because it's like this, if the temperature is 100, you're going to have how many coffee sales, and if temperature is 0, you're going to have how many. If temperature is 5, you're going to have how many sales, and something like that. And it is possible to predict, so that's what you're trying to do. And how you can do it is that, because remember we talked about, we're only dealing with the linear model. So if we can create a model, ideal, the regression model like this, then we can predict, the points between these. For example, in temperature 80 and its temperature 70, but what if temperature is 75, 76, 78? You can predict that using this line. What if temperature is here between 30 and 40, 35 for example, or 31? You can predict that. And you can predict that beyond these lines and points here, and because it goes on and on, it keeps going. So what if it's 0? You can predict that too, because 0 is going to be the end of this line here. Okay. Then, once we've determined this regression model, we can predict the sales for any temperature. That's what we're trying to do. Mathematically speaking, it's really, it's like elementary school math thing. However, there's some problems with that. Okay. The key thing in regression is to determine the line that best fit the data. So in other words, this is going to be the distance between this line and the dots we want to have the line that minimizes, that could be the distance can be the minimum, the smallest. We're going to find the line that, like that. And how do we determine that exactly? How do you do that? Okay, this is a model. It's going to be unlike math, we're using kind of confusing, switching things around, confusing the alphabets here, but y equals bx plus what a, and a is, that's b is a slope, and a is intercept. So determining the regression line boils down to solving the slope b and the intercept a. And a and b are commonly called regression coefficients or constants. Luckily, the formulas for the slope and intercept are reasonably simple, and there's one predictor. I had I'll stay in class after the class and kind of ask questions about why, you get this slope by doing this. So we're not going to cover this because it's going to take a long time to figure this out and explain this. But this is how you get this. It's sum of power, and this is sum of square x. Not sum of power, I mean sum of products. Sum of products divided by sum of square x, and you get the slope. Okay, and it's pretty simple. And once you know that, you can actually come up with this formula for slope, not slope, but intercept. And this is logically, this makes sense logically. So slope, not slope, intercept is going to be mean of y minus b times mean of x. Okay, and I'm going to explain that on a different video, because here that takes too long. So okay, so you get, mean is that, mean of x and mean of y, and sum of square for x and sum of square for y, and it's the sum of products. So to calculate the slope b and intercept a, okay, so you use those formula, and sum of product divided by sum of square. X is going to be the slope, so that and that. So slope is going to be minus 0.87. It's pretty simple. If you memorize the formula, it's really going to be easy. Piece of cake, piece of mochi, onigiri. Okay, then this intercept is going to be mean of y minus b times mean of x. So it's 79.31. So you get this model, regression model, y equals to minus 0.87 x plus 79.31. Using this model, now you can estimate the coffee sales according to the temperature. So use the regression model to predict coffee sales when the temperature X is 40 degrees, for example. Then you get 44.51 sales. Of course, you can't really get the 0.51 sales, so in this case, you would have to go with 44. Well, actually, it says 45 cups. Okay. Why is that? Anyway, 45 cups of coffee when it's 40 degrees. That's how we're going with it. Then, yeah, I'll just stick with it. Okay, just like that. Okay, use this and predict coffee sales when temperature exceeds 60 degrees. Same thing. Y is going to be 27.11, so that's 27 cups of coffee. Coffee sales. Like that. Okay, here. It is this, if you know math, it's obvious, but this number is when the temperature is 0. I mean, when x is 0. So when the temperature is 0, then this is how much the coffee set is going to be. Just like that. So does it make sense if I say the change in the predictive value of y? Okay, the slope b is minus 0.87. It is actually the change in a predictive value of y. So it changed minus 0.87 difference. It's gonna make a difference of this much per 1 unit increase in x. So 1 unit is like temperature, so with 1 degree up and down, this is gonna change 0.087. That's how much it changes. If it changes by 2 degrees, then it's gonna change twice this number. Why is it so important? But anyway, if you know the math, it's obvious. And then this is also obvious. When the temperature increases by 1 degree, then this amount is going to be added. So that's what I want. I think it's really nice to be able to visualize that. So yeah, that's just like that. Okay. So let's look at the example. We're gonna do an example in my next video.